Here we go. So this is section 4.3. All right, quick refresher of 4.2. So write equation point slope form, given a point and a slope. So I'm given a point and a slope. Again, reminder from yesterday's notes. If you didn't watch yesterday's, go back and pick it up. But it gives me the point, it gives me the slope. So I have the formula for point slope form. Gives me the two values. X is -5, y is -7. Watch your negatives. When I put a negative in here, that's going to turn into plus. The slope it gives me is -3. X, when I put -5 in here, it's going to turn into +5. Then we're 2 steps away. Distribute. Subtract 7. To get the final answer. I'm going to check and see if that's on the video. Yeah, perfect. So, those are the steps we did yesterday. Very important to remember because today we're going to be doing that a lot still. So, how can you recognize lines that are parallel or perpendicular? So, what do you know about parallel? I wish we could ask questions right now. Parallel lines, two lines in the same plane that never intersect are parallel lines. What's important for us for this exercise, parallel lines have the same slope. Write that in your notes. Parallel lines have the same slope. All right? Determine which of these lines are parallel. Well, the only way I can determine if they're parallel is if I know the slopes, because they all kind of look parallel. So I need to find the slopes. So this is -4, 3. This is 1, 2. How do I find the slope? Slope formula. Second one minus the first one. Second one minus the first one is -1. That turns into +5. So the slope here is -1/5. Do it again. Second one minus the first one. -1 minus 0. 1 minus -3 is -1/4. So do these two have the same slope? Nope. Let's check the last one. So, second one minus the first one. -5 minus -4. Second one minus the first one. 2 minus -3. This is plus, comes out to -1. This is plus, comes out to 5. So this is -1/5. So A and C are parallel, B is not. There you go. So I told you we're going to be writing equations. How do we use that to write equations? Well, it says write an equation of a line that passes through. So here's my point. Oops. And is parallel to this line. So you're going to see that a lot today. It's not going to tell you what the slope is. It's just going to tell you that it's parallel to another line. Well, if I look here, what's the slope of this line? 2. So if I'm parallel to that line, and that line has a slope 2, this line has a slope 2. So once I know that, I can use that information and write my own line. So here's my point, y minus y1, slope is 2x minus x1. Just like we did the other day, distribute, get y by itself, done. So it's not going to specifically tell you the slope of the line the line you're looking for. It's going to tell you, hey, I don't know this one, but it's parallel to this one. All right? So, if it tells you line A passes through a couple of points, line B passes through a couple of points, how can you tell if they're parallel? You find the slopes. Find the slope of the first one, find the slope of the second one. Same slopes means parallel. Write an equation of a line that passes through and is parallel to this. Let's do this one more time. If I am parallel to this line, what's the slope of this line? 1/4. So that means, here's my point, here's my slope, y minus y, x minus x. Distribute. Get y by itself. There's the equation. All right? So, the other thing we talked about is perpendicular. So what does that mean? Well, two lines plane intersected perpendicular lines. What's important for us, their slopes are negative reciprocals or opposite reciprocals. So what does that mean? So if I have a slope of 3/4, this upside down T means perpendicular, by the way. Shorthand. You'll see me write that a lot. So if I have a line that's slope is 3/4, what is the opposite reciprocal? What is perpendicular to 3/4? Negative reciprocal or opposite reciprocal. I change the sign and flip the fraction. I don't want you, whatever junior high teacher poisoned your brain with keep, change, flip. That's not this, and don't ever say that again. If I have a slope of 4, the opposite reciprocal of 4, well, the reciprocal would be 1/4, opposite reciprocal would be negative 1/4. If I have -6, the opposite reciprocal, the opposite would be positive, 6 would flip to 1/6. So that's how you do, and you can tell if things are perpendicular. So if we have these two lines here, this line has a slope of 1/2, this line has a slope of -2. Those are opposite reciprocals, so these are perpendicular lines. So what does that mean to us? 3 lines tell if they're parallel or perpendicular. So I don't have graphs of these, I don't have points, I have equations. So if I look here, it's in y = form, the slope here is 4. All right, cool. This is in standard form. I got to get the y by itself to find the slope. So the equation looks like this. I got to get y by itself, then I'll be able to tell what the slope is. Subtract x from both sides. We've done this before. Now I got to get y by itself. So I divide everything by 4. We've talked about this in previous videos. There's a 1 here, so that's -1/4 x plus 3/4. What's the slope? -1/4. Okay? And line C. Same deal. I got to get y by itself. So add 2x to both sides. Divide by -8. When I divide by -8, I get -1/4 x minus 2. So the slope here is -1/4. So what does that tell me? Well, these two have the same slope. They're parallel. This has a slope of +4. So it is perpendicular to both of these. So what's going on here, just to give you like a rough sketch, it would be something like two lines are parallel. This is perpendicular to both of them. Now this is not the exact graph, obviously, I just sketched it, but that just kind of gives you a visual of what's going on here. And the way you can figure that out is by finding the slopes. Get them in y = form and look at the slopes, determine parallel or perpendicular. All right, so what if I tell you a point and I am perpendicular to a given line? Well, I look here, what's the slope? What would a perpendicular slope be? Do the opposite reciprocal, and that's positive 1/3. Flip it, change the sign. Okay? So, now I go about doing what I've been doing. Y minus y equals, use my perpendicular slope, x plus x, and finish the problem like we've been doing. Distribute, get y by itself, and there you go. So if I tell you it's parallel to a given line, use the slope that's in the line. If I tell you it's perpendicular to a given line, use the opposite reciprocal of that given slope. All right? So, I know it's hard to read, but this says that there is a rescue crew in a helicopter. It wants to know the shortest distance in a straight line. You got to find the equation of the perpendicular line. So, what do I know? Not much. I know a point. So I got my 14.4. I can't write it zoomed in, sorry. I got my point, I got 14.4. I can't really see where they cross. I can't see another point on there. What do I need when I write these problems? I need a slope somehow. Well, can I find the slope of the green line? Well, we've talked about this. In order to find the slope of the green line, I got to find 2 points where it goes through exactly. So I'm thinking, kind of goes through exactly right here, and it goes through exactly right here. So I'm going, now again, let me unzoom so you can see what I'm talking about. I'm going down to right 3. Now, obviously, if I give you this on big ideas, it'll be a whole lot easier for you to see and read, but I just want you to get the general idea. I gotta find 2 spots where that line goes through exactly. We've done this before, okay? So, I know the slope of this line is negative 2/3. What's the slope of the perpendicular line? Opposite reciprocal, positive 3/2. So now it's a point and a slope. Y equals 4, y minus 4 equals 3/2, x minus 14. Because I have that point right there, 14.4. Finish the problem like normal. Get y by itself. Minus 17. And now I have the equation of the perpendicular line for the helicopter to fly. There you go. There you have it. There you are. Questions, comments, issues. We're going to have a review on big ideas on Thursday, quiz on Friday. Make sure you are keeping up with this stuff, boys and girls, and you are reaching out to me if you need anything. All right, take care. See ya. Sometime. Soon, hopefully.